All right, welcome back. This is Chapter 8, Section 2, entitled Graphing Simple Rational Functions. You're definitely going to want to have your calculator handy because we're going to be doing a number of, pretty much all of the graphing with the calculator. We'll be looking at the table that the calculator provides for you as well. So first of all, a rational function. Well, what is a rational function? A rational function is a function of the form. So you're given a function, and it is a function that is composed of multiple functions. So something like this. These are all polynomials, and there are some certain rules about polynomials. They're all polynomials, and the most important part is that the denominator cannot equal or does not equal 0. Hopefully you remember from domain and range that whenever a denominator is 0, it's undefined and therefore not part of the actual domain. So, rational functions. The parent function for a simple rational function looks like this. The graph of the parent function is a hyperbola. So hyperbola, which consists of two symmetrical parts called branches. The domains and ranges are all non-real numbers. Non-zero, all non-zero real numbers. The asymptotes are at x equals 0 and y equals 0. Any function of the form g of x equals that has the same asymptote. The same asymptote, the same domain, and the same range as other functions that are parent functions. Basically what this means for functions that look similar to this, meaning you could have 4 over x, or you could have 5 over x. Anything that's just one number and just the variable x in the denominator, that is a parent function for a simple function. The asymptotes are always this. The domains and ranges are all non-real numbers. Basically what this means is you can say that x does not equal 0 and y does not equal 0. That's how this is set up. So again, the parent function basically is y equals 1 over x. The child function, and we'll talk more about this later, the child function ends up having some more pieces to it. You're going to have y equals, you're going to have a number all over x minus h. Look, there's that minus h again, plus k. This should be another time that you see an x minus h, of course in parentheses, and a plus k. We're going to talk about how to read this in just a little bit. Now, first of all, this is a parent function. So when it's a parent function, you know the asymptotes are x equals 0 and y equals 0. So that means that there is now an asymptote that kind of sketches across here. Sketches across here. And now it's a matter of determining what the graph will look like. And what you'll notice is that some of these points, they kind of look like parabolas that are tilted a little bit. They're curved lines. They never actually touch these asymptotes. So in your calculator, you put in y equals 4 divided by x. And then you're going to look at, for number 2 here, use the table function from your calculator. So you can actually label some of these points. So use your table function. You'll find that negative 2 maps onto negative 2. Negative 1 maps onto negative 4. 1 goes to 4, and 2 goes to 2. So what you'll do is you'll plot those points. 1, 4, use a different color here. 1, 4, 2, 2, -1, -4, -2, -2. And what you've got, when you hit graph on your calculator, you've got an equation that kind of curves around like that, never actually touching those asymptotes. So you draw the branches of the hyperbola, so they pass through the points plotted and approach the asymptotes. Notice it says approach because it doesn't actually touch it. So here's one to graph on your own. Notice this is a parent function once again. So you're going to type y equals 3 divided by, I would get used to putting the x in parentheses. You're going to look at the table, and you're going to find some points from that table. Like if you look at -3, it'll plot onto -1. If you look at -1, it goes to -3. If you look at 1, it goes to 3. And if you look at 3, it goes to 1. So here are a bunch of your points. Now, the asymptote is y equals 0, x equals 0. So you have asymptotes here in the blue lines that doesn't actually touch that line. So now let's plot the points. -3, -1, -1, -3, 1, 3, 3, 1. And you draw as well as you can a nice curved line that doesn't actually ever touch the parabolas, or the asymptotes. Now we are forgetting about domain. For these, the domain, the easiest way is just to say that the domain does not equal the asymptote. The range does not equal the asymptote. Does not equal what the asymptote is. The range does not equal what the asymptote is. That's going to be the best way for you to look at this. Now, here we are with the translation of simple rational functions. You're going to use a calculator for this still. So the asymptotes for this are at x equals h and y equals k. So whatever makes this opposite is the asymptote. That should make it easy for you to know what the domain and the range is, because the domain is where x does not equal the asymptote. Range is where y does not equal the asymptote. Draw points to the left and to the right of the vertical asymptote. So you basically just look at the table. Not took. Look at the table. So you're going to look at the table. Then you're going to draw the branches, the two branches. So please remember that the parent function is y equals 1 over x. The child function is y equals a over x minus h plus k. So when you graph this in your calculator, you'll go to the y equals menu. You'll type the a number divided by, in parentheses, x minus h, and then you plus k, and this tells you everything. It tells you the asymptotes right away. It tells you the domain and range right away. Your calculator will tell you what the points are that you need. It should be a piece of cake after that. So, take a look at this. Remember, the asymptote is the number that makes this equal to 0. So for this, what makes x plus 3 equal to 0, or what's the opposite of this? X equals -3. That's your asymptote. Immediately, you should be able to recognize that the domain, then, are all the x's except for the asymptote. This number here is simply your asymptote for y. Once you know the asymptote for y, you immediately know that the range is that number. So for us here, it's a plus 2. So I erase that k there, and we're putting it in as a 2. That is your domain, and that is your range. So part 2 here, number 2 here says, oh wait, let's actually graph that at those asymptotes. So y equals 2, right there. That's y equals 2. Then x equals negative 3. So we go right down the middle of that. That's our asymptotes. Now let's graph our points. You look at the table from the calculator. So number 2 is done on the calculator. Negative 6 maps is 4. Negative 4 is 8. Negative 2 is negative 4. And 0 is 0. So negative 6, 4. 2, 4, 6, 2, 4, negative 6, 4. Negative 4, 4, 8. 8. So we have a graph that looks like this. Negative 2, negative 4, and 0, 0. Now we have a parabola that curves like that. There's your hyperbola. Now there are some other radical functions that you need to be worried about. Other radical functions will come in this form. You're going to look at y equals ax plus b all over cx plus d. Now, a, c, b, d, they're all non-zero. A, b, c, d are all, could be positive or they could be negative. The important part here is that you need to recognize that the vertical asymptote, now this is again something you should be adding on to the side of your notes. Vertical asymptote is x equals negative d over c. So whatever d and c are, it's negative d over c. So that's when this bottom part is 0. So that's the asymptote. That means then that the domain so you would say then that the domain is x does not equal negative d over c. All right, the horizontal asymptote is y equals a over c. That's where the horizontal asymptote is. You're going to want to write this down again, please. Y equals a over c. That means then that the range is y does not equal a over c. So we're going to be using those other rational functions here on the next couple of problems. So here we go. Look at this. 4x minus 2, x minus 1. It's all set up like that. State the domain and range. Come up with the asymptotes. All that stuff we have to do. So from over here, you should see that the asymptote is negative d over c. So for this, 4x minus 2, x minus 1, this is a, this is b, this is c, and this is d. So when we plug this in there, d over c, well, d is negative 1, c is positive 1. So the asymptote, the vertical asymptote is x equals negative 1 over 1, or 1. That is the vertical asymptote for example number 3. the horizontal asymptote is a over c. So now we're looking at the top numbers. Here's a, so a is 4. B is -2, so a is 4 over -2. Oh, I'm sorry. It's not over, that's not c. C is right here. So c, we don't actually care about the b at all, do we? So we care about the 4 and the 1. So it's 4 over 1, and the asymptote is at 4. So let's draw those in there right now while we have a chance. The vertical asymptote's x equals 1. So draw straighted line as possible. The horizontal line asymptote is here. Now let's find some extra points. Use your graphing calculator. Plot this in there. So in the calculator, you're going to type y equals, in parentheses, 4x minus 2, divided by, in parentheses, x minus 1. And when you look at the table, you should come up with -1, 3, 0, 2, 2, 6, and 3, 5. You need just some points to the left and to the right of the asymptote. So -1, 3, 0, 2. All right. Hopefully in class one of you would have stopped me and reminded me that, Mr. Andre, we don't graph from the asymptote, we graph from the origin. So -1, 3 is right here. 0, 2 is right here. Or, man, I'm still doing it wrong. Here we go. Third time's the charm. -1, 1, 2, 3 goes there. 0, 1, 2 goes here. Now we have our 2 points and the fact that they don't ever touch the asymptote. Now 2, 1, 2, 1, 2, 3, 4, 5, 6, 3, 5. We have our points. You can now graph the line and it never touches the asymptote. So the reason the asymptotes are so important is they then tell us that the domain are all real numbers except for 1, and the range is all real numbers except for 4. That's how this is set up. So let's do a couple of the checkpoints here. This here is the parent function. This is the x minus the h. You could actually view this if you wanted as, you could think of this as either the parent function of a hyperbola, or it could be 0x plus 3 over 1x minus 2 plus 1. But we're going to look at it in terms of the parent function. So going back, we know right away that the asymptotes are x equals 2, y equals 1, because it's what makes this 0. There's the 1. Go back to the notes I gave you previous. That automatically tells us that the domain is all real numbers except for 2. Our range is all real numbers except for 1. And now it's a matter of coming up with some points. So typing this into your calculator, you would do 3 divided by x minus 2 plus 1. Put that in the calculator, come up with some points such as -1, 0, 1, -2, 3, 4, and 5, 2. So let's sketch the asymptotes at x equals 2, y equals 1. Let's draw the graph, or plot the points. -1, 0, 1, -2. There's your half of the hyperbola. Then we have 3, 4, and 5, 2. So it looks like everything you need for that graph. All right, let's take a look at the next checkpoint. This one is in the form of the ax plus b over cx plus d. And you need to refer back to this page right here that tells you exactly where because once you know the asymptotes, everything you can do is all set. So take a look at it, try to come up with the asymptotes, and I'll write them down here in a second. All right, so looking back at the notes that we just took, you can see the vertical asymptote is negative d over c. So x equals negative d over c. In this case, d is negative 2, so negative 2, all over c, which is negative 1. So our vertical asymptote is x equals negative 2. When you have that, you then know that the domain is all reals except for x does not equal negative 2. Now the y. The y asymptote, if you scroll back to the notes a few pages before, you should have written this down in your note-taking guides. The asymptote is at a over c. That's the horizontal asymptote. A over c. For this situation, a is negative 2, c is negative 1, so our vertical asymptote is y equals 2. That now tells us our range is y does not equal 2. So we have vertical asymptotes. We have vertical asymptotes at negative 2. We have a horizontal asymptote at 2. And now you can use the points that you find in the calculator and the sketch of the graph to get a very good sketch of this. So find those points in your calculator, fill in these points right here, put them on the graph, draw your lines, and see how it looks. All right, so for this, your calculator, the table of values, you should have points like negative 7, 3, negative 3, 7, negative 1, 3, and 3, 1. So when you plot these points, negative 7, so 2, 4, 6, 8, negative 7, 3, negative 3, seven, and now you have a hyperbola. On the other side, it's negative 1, 3, and then it's negative 1, 3, and then 3, 1, and you get a line that does not touch the asymptote. That's how this is set up. Right. We are done with the note-taking guides. We're going to do a couple guided practices that should help you with the graphing of these. So number 1 is a nice parent function, y equals negative 4 over x. The asymptote is x equals 0, therefore the domain is x does not equal 0. The range is, the y asymptote is y equals 0, therefore the range is y does not equal 0. And then you come up with some points. Since the asymptote is at x equals 0, you need something to the left of 0. So let's do negative 4, let's do negative 2. And to the right of 0, let's do 2, and let's do 4. You plug those, you look at the table, you come up with these points, plot them on a graph, you should be good to go. So go ahead and find those values, put them on the graph, and we'll go from there. All right, so these were the points you should have come up with. you should have an asymptote that goes through 0, and another vertical asymptote goes through 0. Should be better than that, though. A point at negative 4, 1. A point at negative 2, 2. A point at 2, negative 2. Point at 4, negative 1. Once you have that, you should be able to draw your hyperbola. So the graphing part really isn't too tough. Coming up with the asymptotes maybe. So if you take a look at checkpoint guided practice number 3, it has y equals 1 over x minus 3 plus 2. All you have to remember is that this tells you the x asymptote. This tells you the y asymptote. These together then tell you the domain is x does not equal 3. The range is y does not equal 2. Guided practice number 5 is y equals 2x plus 1, 4x minus 2. And now, the x asymptote, you need to go back to your notes to see that the x asymptote is negative d over c. So it's this divided by that. So negative 2 divided by 4. So the x asymptote is 1/4. The y asymptote is this number divided by that number is 1/2. So this is the vertical asymptote. This is the horizontal asymptote. Together, then the domain is x does not equal 1/4. And here the range y does not equal 1/2. I think you can pretty much take care of it from there as far as graphing is concerned. So, and we're going to forego number 7. This should help you now with doing the practice problems. I would take a look at some of these, but we will work on the majority of them in class. Good luck.